Hi, everyone. My name is Jong-hee Park. I'm a faculty of Political Science and International Relations. I will moderate the afternoon session on AI. So we have 5 presenters, and each presenter has 15 minutes for presentation. And after 5 presentations, we will have a short break, 15-minute break, and then we'll hear from 2 discussants. So let me introduce our first, so the topic of AI session is 3 topics. The first topic is AI technology in general. And in this session, Kai-Shen Huang will present a new AI index for East Asia. And the second topic is AI hardware. So Jinwon Lee and Conrad Young will present on this topic. And the last topic in AI session is AI application in industries. And Seongbin Lim and Lichi Tsai will present, will make a presentation on this topic. Our first presenter is Kai-Shen Huang. He's trained anthropologist and lawyer, and his expertise include critical technology policy in China and application of AI in public administration. In this talk, he will present a new AI index for East Asia. And if you all remember, early this year, the Stanford University published AI index, and one of the criticism was that companies and institute in East Asia were highly reported in that report. So I think this new measure focusing on East Asia will be a really valuable contribution to AI research. So please welcome Dr. Kai-Shen Huang.
Thank you for having me. It's such a great pleasure to be here today. My name is Kai-Shen Huang. I'm the team leader of the AI and Cybersecurity Research Unit at DISET. So my aim here today is really to suggest a proposal for collaboration on a new AI index for East Asia, and in particular, for the very 3 leading economics in global chip industry: Taiwan, Korea, and Japan. In a way, I'm trying to find a more effective way of presenting many of the problems all the presenter raised here this morning. So, and over the next 15 minutes, I'm trying to answer 3 key questions. Let me start my first question. Why do we need a new AI index for East Asia? Or to hedge a bit, an AI index from an East Asian perspective. Now I know you may be wondering, the global assessment, as Professor Park just mentioned, on AI performance have been abundant. And yes, they have, and they are useful. But here is the thing, they are missing something crucial when it comes to our region. And think about it, Taiwan, Korea, and Japan, they are not just any players in the AI game. They are really the backbone of global chip industry and their technological ecosystem, their innovation culture and the challenges. These are all really unique. And let's be honest, a one-size-fits-all global index just doesn't cut it. So especially when it comes to getting what's really happening here in this region. So I think we need something that speaks our language, an index that understands the nuances of our market, our regulatory environment, and our technological strength. Because when it comes to AI and chip production, East Asia is not just participating, we are actually driving the bus. So that's what my presentation is all about today, to talk about an index that really gets us, that kind of guide our policy and can enhance our investment, and crucially, an index that can lead our collaboration in a way that general global index just can't provide. So that's the next slide. All right, so you may be wondering, why are we making such a big deal about an AI index? Or more to the point, why would a government even need an index for something like AI. Well, imagine you are trying to navigate a city without a map. That's the kind of what it's like for government around the world dealing with AI without a good index. They are trying to make decisions about this game-changing technology, but they are doing it in the dark. And so an AI index is like turning on the light. It helps government to see what's really going on with AI in their country, how fast it is developing, where are we strong, where do we need to catch up. Without this kind of insight, it's hard to make smart choices about where to invest, what policy to create, and how to compete on the global stage. But it's not about keeping score. A good AI index can help spot trend early, guide research funding, and even signal to the rest of the world where the opportunities are in the region. It's a tool for development, plain and simple. So that's the two keywords I want to present in this slide, state legibility and development. So when we talk about state legibility, we are talking about a government's ability to understand and act on what's happening in this crucial tech sector and today's world. If you can't read your own AI landscape, you are already falling behind. Another reason for a new AI index, AI is going to be the future of innovation power. You see, AI isn't just another tech trend. It is the engine that's driving the future of innovation, especially in our neck of the wood, that is the global chip supply chain. But here is where it gets really interesting, because AI and our semiconductor industry are in this amazing feedback loop. AI is pushing the boundaries of what chips can do, and in return, more advanced chips are enabling more powerful AI. It's like a high-tech dance, and we are leading it. This is why understanding AI development is so crucial for us. It's not just about keeping up with new technology. It's about leveraging our existing strength in semiconductors in order to stay at the forefront of global innovation. So when we talk about an AI index for East Asia, we are not talking about measuring progress. We are talking about a tool that can help us align our AI development with our semiconductor supremacy. It's about cementing our place as innovation powerhouse of the future. But as I am turning to the next slide now, these considerations are largely neglected by international assessment by Western countries. So let's take a moment to look at three reports that really stirred things up among AI policymakers in Taiwan early this year. We've got the AI Index reports from Stanford Human Center Institute and the Government AI Readiness Index from Oxford Insight. And finally, the Global AI Index from Tortoise Media. Now, I'm not going to dive into the details of each report. What's important is the reaction they caused. This report got our policymakers arguing about how Taiwan's AI capabilities are being measured and perceived on a global stage. And one common view was that Taiwan didn't do well, and in many cases was even worse than China. So let's get to the heart of the matter. We've looked at these three Western indices, and frankly, we've got some issues. And I'm not talking about where we rank. I think we're doing well. But that's not the real problem here. I think the real issue is that these three indices are not painting the accurate picture of what's really happening in Taiwan. And if we are not getting a true representation, how is that even possible for us to make correct and effective policy decisions? So that's one of the key points I want to make in this report. And it's more like trying to sort of navigate using someone else's map. It might work in general, but it's going to miss all shortcuts and local knowledge. So this kind of disconnect has led me to write an article that just came out in Diplomat a few days ago. It's called Decoding Taiwan's True AI Potential. But more than that, it's a call to action. So now let's look at pretty challenging issue in the HAI report from Stanford. In this report, there is a data distortion that's more than just a statistical hiccup. It's a statistical hiccup, really. Taiwan is actually grouped together with China and Hong Kong. When Taiwan gets lumped in with China and Hong Kong, it's like our individual identity in the AI world get erased. Our specific strength and our particular area of growth and our unique regulatory environment, all of that get lost in the mix. So this kind of data distortion doesn't just misrepresent Taiwan. This can lead to first, like misguided policy recommendation, and second, missed opportunities for international collaboration. Another problem with this data distortion, let's look at another example. This one is from the Oxford Insight report. And honestly, when I first saw it, I thought there must be a typo. Get this, in that ranking of data protection and privacy legislation, Taiwan was placed 140th out of 193 countries. That's near the very bottom of the index. And here is a kicker. In the same report, China was ranked first in the world. So this isn't just a minor discrepancy. I think that's a fundamental misrepresentation that could have serious implications. Imagine a foreign investor or policymakers looking at this report. They are going to get a mistaken view of data protection landscape in Taiwan. So let's dig into this data protection ranking a bit more. As I mentioned in my recent article, I think there's a lot more to the story than what Oxford Insight report suggests. The truth is, Taiwan has had a comprehensive Personal Data Protection Act. This act was first enacted in 1994 and had undergone several amendments. And of course, there remain potential for further improvement, but it does set out clear requirements for the collection, the use of personal data by both governmental and non-governmental sectors. So apart from data distortion, I think another problem with international global assessment on AI at the moment is they are inadequate. So these Western AI indexes are not just inaccurate, they are really often inadequate for our own need. I mean, like Korea, Japan, and Taiwan. Let me show what I mean. Check this out. According to the Inside Monkey recent report, Taiwan, South Korea, and Japan are the top players in semiconductor manufacturing. I'm talking about the top 3 market share position globally. So that's kind of huge, right? Now, you might think this would translate into a higher ranking for talent performance in AI tech. But here's where things get weird. The LID World Talent Ranking for 2023 put Taiwan at 20th, South Korea at 34th, and Japan at 43rd. So that's kind of the sort of data inconsistent in this report. So does that make sense to you again? How can we be so? How can we be world leaders in some of the most complex high-tech industry on the planet, but rank so, let's say, modestly in talent? So this disconnect highlights a big problem with these global indices. They are not capturing the whole picture. They are not adequately reflecting the unique strength and weakness, in particular, of our region. Okay, so I'm gonna skip this slide to the very end of the presentation. Collaboration. Now here is where you may come in. I believe that by collaborating on this kind of index, we can create something that truly reflects unique strength and the challenges of our region, something that speaks to our shared experience as leaders in the global tech ecosystem and help us to understand better our shared challenge as well. Thank you very much.
Thank you very much for the very interesting proposal. And I think it's very timely proposal because not just the ranking, but in terms of international regulation on AI, East Asian voices are very, very underrepresented in global discourse, even though the Taiwan, Korea, and Japan are leading countries in AI and semiconductor industry. So this type of a proposal is very, very timely and important. Our next speaker is Jinwon Lee. He is a technology expert with a background in electrical and computer engineering. Now he is affiliated with HyperXL, and he's a Chief Technology Officer at HyperXL. Please welcome Jinwon Lee.
Thank you for inviting me to speak here today. I am Jinwon Lee, the CTO of HyperXL. HyperXL makes the AI chip specialized for large language models such as ChatGPT. Today, I will talk the technical aspect of the challenges faced by advanced AI chips and strategies to overcome those challenges. Okay. Let me start with the first figure. This figure illustrates the progress of AI system relative to human baseline for 9 AI benchmarks, for example, image recognition and basic level reading comprehension. The dotted line represents the human performance. As you can see, AI hasn't yet surpassed the humans in all tasks. But as you can also see in the graph, it's clear that AI is showing superior performance to humans in certain tasks. And in tasks where it's still lacking, it's rapidly catching up to human abilities. The AI chip market is experiencing rapid growth. Various institutions release different forecasts every year, but all of them are talking about an annual growth rate of over 20%. And for now, as we all already know, the AI chip market is dominated by NVIDIA. According to last year's survey, NVIDIA GPU are used to 31 times more than FPGA in AI field and 150 times more than other AI-specific ASIC chips. GPUs can be considered one of the main contributors to the current advancement of AI technology. However, NVIDIA GPUs are struggling to fully support the rapidly growing demands of AI, and their high prices and high power consumption are also becoming issues. That's why many companies worldwide are making AI chips that are even more optimized for AI. There are many startups in Korea making AI chips. To briefly introduce a few of them, HyperXL along with Rebellions, Furiosa, and Sapion makes an AI chip specialized for server and high-end edge device such as robots and cars. And Mobilint and DBEX are developing AI chips needed for smaller sized edge devices. I hope all of these companies will grow well together and produce excellent results in collaboration with many companies and schools from these 3 countries. Okay, now I delve into the challenges and strategies. The first graph is taken from the presentation given by David Patterson, a renowned expert in computer architecture. It shows the performance improvement of general purpose processor like CPUs over a 40-year period. In this presentation, Patterson said the Dinard scaling and Moore's law have essentially come to an end. So we have entered an era of domain-specific architecture rather than general purpose processor. There are some disagreement of the end of Moore's law, but it is undeniable that the benefits from semiconductor manufacturing processes are visibly decreasing over time. AI chip is one example of domain-specific architecture, and the concept of domain can be interpreted multiple ways here. I think a domain could be the entire field of AI or a specific algorithm such as transformer and convolutional neural networks, and or industry sectors like mobile, automotive, robots. As you can see, various companies are developing chips specialized for the different domains. There's no single correct approach, and given the rapid growth of AI field, creating chips specialized for this diverse domain with AI can be good strategy. As AI is rapidly and changing, evolving, the algorithms that will run on AI chips are crucial. Currently, the most influential and significant model is a large language model. In 2023, about 30,000 models have emerged in Hugging Face, the platform where open source LLMs are uploaded. There are roughly 20 pre-trained models and 40 application models, over 30,000 fine-tuning model being produced. New LLMs continually being developed, and even now. So let's take a closer look at LLMs. I believe everyone here has used the LLM like ChatGPT, Gemini, or Claude. As you can see, when a user asks a question like, is tomato a fruit? The LLM generates an answer one word at a time, one by one. The sentence input by the user is called prompt, and the phase of processing this and making the first word generated then becomes the input for the LLM again. From this point on, as shown in the figure, it operates on auto-regressive manner, where the word generated in the previous step becomes the input for the current step. This is called the generation phase, and the former phase called prompt phase. Since LLMs are basically designed to generate one word at a time, so it takes, in this figure, it takes 4 iterations to answer with a total of 4 words up to end of sentence tokens. Therefore, generally, the number of execution in the generation phase is longer than the prompt phase. The issue is here that LLMs are very, very large, considering the generation phase. One word goes in as input, and one word is generated as output. But for this, the entire LLM must be read from memory at least once. In the case generate a single word, in the GPT-3 case, there are 175 billion parameters. It is typically correspond to 350 gigabytes. So this means that every time GPT-3 generates a single word, it needs to read at least 350 gigabytes of data from memory. And the problem doesn't stop here. As you can see, we want to be able to process a longer input prompt, and we want to make a larger LLM model, and we want to process the output faster. And the core of all this problem is memory. The graph is upper right is called a roofline model. The x-axis represents the arithmetic intensity, which shows how many operations can be performed when data is read once from the memory. The y-axis represents performance, which is the number of operations can perform per second. So the red area indicates the memory bound, while the green area represents the compute bound. As you can see, the generation phase is always memory bound. As mentioned earlier, this is because they need to read a very large amount of data from memory each time to generate one word as output. That's why to speed up LLMs, we absolutely need memory with higher bandwidth. This is the reason HBM is widely used in AI chips, including GPUs. And another issue is that LLMs are so large that requires a lot of memory space for storage. To run GPT-3, you need at least 5 of the latest GPU like the H100. This is due to the limited memory capacity of GPUs. Therefore, along with bandwidth, one of the most crucial factors is memory capacity. HBM technology is advanced very rapidly, but so far DDR has an advantage in this aspect. Generally, AI chips using DDR have lower bandwidth but can have larger capacities. The two graphs at the bottom show that memory storage space and bandwidth are developing relatively slowly compared to the rate with AI model size, and the number of compute units in GPUs are increasing. In particular, the green line in the right graph represents memory bandwidth, and the blue line represents the bandwidth of interconnect, which is communicate between chips. We can see the performance of the interconnect is slower than memory bandwidth. So therefore, using a smaller number of chips to learn large language models can be a good strategy for achieving high performance. In this aspect, DDR-type memory can have an advantage. I think choosing the right memory according to the situation and purpose is an important strategy in making AI chips. In some cases, I believe it's possible to use a hybrid form that mixes the two types of memory. Another issue is facing LLMs and AI chips concerns cost. The left graph shows the cost required to train LLMs. For Gemini Ultra, it's reported that the training cost was about $200 million. The two graphs on the right side are about carbon dioxide emissions. The upper graph represents the emissions during training, and the lower one represents the emission during inference. Looking at the training case, we can see that GPT-3 emitted more than 8 times the amount of carbon dioxide and a single car produces during its entire lifetime. And this cost issue is closely related to the power consumption of AI chips. The table of the right summarizes the specifications of NVIDIA's latest AI dedicated GPUs, V100, A100, and H100. The graph on the left shows the values of the memory bandwidth and capacity divided by TDP, respectively. You can see in the graph bandwidth or capacity per watt improved when moving from V100 to A100. But we can also see that the degraded again with the H100. So creating a power-efficient architecture in AI chip is crucial. While it is difficult to discuss the technical details, as this could be a core technology for each company, but it's not just about designing good architectures. For example, fine-grained management of clock and power is becoming more and more important. There are also very active efforts to reduce the size of AI models themselves. Quantization, pruning, knowledge distillation. But there are some crucial considerations, since most methods are based on lossy compression. So thorough validation is necessary. Without hardware support, these methods' effectiveness may be reduced or even worsened. So hardware consideration is essential. This is my last slide. A few more challenges of AI chips. First, there is an issue of the extremely long time it takes to develop and produce chips. AI algorithm is changing very fast, but developing AI chips are a very, very long time. On average, it takes over 2 years to design and produce AI chips. So we must consider reusability and scalability from the design phase is essential. And also AI technology should be actively utilized in AI chips designing as well. Google and some EDA companies to apply these techniques, AI techniques to place and route, I think it is a good example. And last one is vertical optimization. We have already reached the point where we are using our computing power to the extreme. So vertical optimization through joint effort of hardware and software is essential. So to achieve this, active collaboration between various companies, academias, governments, and even between countries is needed, I think. Okay, this concludes the content I prepared. Thank you very much to listen my presentation.
Thanks for the very informative presentation. I think there are a lot of kind of point we can pass on to the discussion session to discuss what kind of cooperation areas among these three countries can achieve jointly to overcome this kind of challenge. Our next presenter is Conrad Young, Senior Advisor at DSAT, and he's a former the R&D Director at TSMC. So please welcome Conrad Young.
I don't have a lot to share because I'm not really an AI expert. I'm just coming from Foundry's viewpoint to look at how these AI chips is going on. Okay. For the entire AI application on the top, and then you have a lot of things to enable AI to happen, starting from the ecosystem, foundry, and also heterogeneous integration, and a lot of things finally got to AI. So AI chips, I personally, initially when AI chips coming up, I am very skeptical about this AI chips development. Let me give you a reason why I thought so. I still remember in my first job at TSMC, we start to develop 0.18 micron technology. At that time, I have a system company called Cisco. During the time, they tried to build a chip for themselves, and it failed badly. Okay, Cisco never be able to make any commercially sense chip product because of for the communication protocol at that time was very diversified. And in semiconductor manufacturing, without a volume, it's going to be very difficult to survive. Okay, this is the first system customer I have ever experienced in my first year at TSMC. After several years, Microsoft come in, try to build chips for the system company. Microsoft is a software company, you know. They make Xbox, so they try to build a graphic chip for Xbox, and they kind of ask ATI and later become AMD to develop the chip for that. It's a medium volume, reasonable success, but never been very successful. But they don't build a design group for themselves. They license, they basically outsource AMD to do it. After 2012, I think Samsung used to be ASIC house for Apple. Apple is put it this way, I think Apple is the only system company success in IC chip production because of volume. You know, the iPhone has a huge volume. So that's why I say volume determine the success for IC, okay? And the reason why I have some skeptical about AI chips is NVIDIA is a little bit different. NVIDIA is providing an AI computation platform. They are not any particular application. They basically build a GPU for whatever their application, and they also have this CUDA platform for everybody want to do computation can use the GPU to do it. So that GPU is very generic and can be used a lot. That's why they have a volume, and they pretty much kind of leverage whatever they already done for the past 30, almost 20, 30 years for the graphic chip point of view. Okay, so when AI chips come out, I think the previous speaker talked about. So if AI chips doesn't have a volume, and if you have to use advanced technology, it doesn't make any economical sense to do that. Okay, so some of the AI will be probably leveraged right now. The AI PC is those the chip company try to do a CPU and add some AI volume to that. I think it has enough volume for that because that chip can use for other application also. So that's why when you want to design AI chips, and then you need to think about volume. And when the AI model change as time goes so frequently, how can you make a generic chips to provide the platform application? I think that would be a very interesting challenge. Okay, that's how I look at it, and that's the reason why the packaging company actually mentioned about FPGA. FPGA is one solution. Is very easy to implement for various applications because you took the generic product and you combine together for that particular application. You don't need a high volume for that because you took a standard product, only put into a FPGA. And similarly, 3D IC or packaging approach is the way. Because if you do a SoC, put the AI chips on SoC without a volume, it's going to be a dead end. So the 3D IC packaging heterogeneous integration definitely is one area which is very useful. Heterogeneous integration come long time ago, probably more than 10 years ago. But initially, when Nikki Yitron come to TSMC, try to bring this, try to convince TSMC to the CoWoS or whatever, in the first 3 to 5 years, going nowhere, because it cannot compete with the existing the old set. The cost was way too high. None of our customers want to use it. I think only when Apple start to find there's a good integration for that, you start to create volume. And that's part of the reason one of my bosses called Xiang Yi, he kind of left TSMC because he couldn't see the success of 3D IC, and he was brand every year by Morris. Sorry for some inside situation. So the 3D IC and heterogeneous integration is actually grow in the beginning. This is going nowhere only until there's a business case to come up. So 3D IC right now heterogeneous integration definitely is one trend to develop combined chips so that you have a more application, especially memory plus the processor. Okay, I think it becomes a dominator trend today. So when we talk about AI chips, even for NVIDIA, need to rely on this HBM. I think the previous speaker already mentioned that, and the 3D IC kind of provide that flexibility compared to the SoC. There's no way SoC can do that. And the challenge, I think, is the power efficiency, reliability variation, and especially important, I think, is the thermal. This morning, Professor Huang already mentioned that we had one experience with one customer. When we put a 3D IC together, it actually burned. And we end up with changing the routing so that the hotspot need to be redistributed. So it has a long lesson because the thermal modeling was not very mature for IC industry, and we had to keep learning it. And right now, we work with the EDA vendor, try to simulate, the thermal modeling. I think thermal becomes a new subject for anybody doing research to really understand how did you distribute that heat together, and that's getting very, very critical. Yeah. So anyway, I think the picture doesn't mean anything. I just grabbed anything from internet, so there's nothing fancy. So don't worry about it. The other thing I think the last one I want to mention. Typically, I only talk about the things I know. The things I don't know, I would not spend too much effort. I mentioned this morning about this, I call it intergeneration collaboration. The training, the talent is really coming from. Right now, I've spent most of my effort in school basically focused on 3 areas. One is interdiscipline. For example, thermal modeling and electrical design, and so on, application, software, hardware, even geopolitical, working with the technical policy is the trend in today's world. How do we provide the interdiscipline people, for example, the electrical engineer working with the mechanical engineer, working with the thermal engineer together to co-design, optimize the chips. So interdiscipline is the trend that everybody need to spend on, especially in Taiwan today because of the high-tech, the trend, the flux, NVIDIA, the so-called Jensen Huang's the inference. So it kind of lead to Taiwanese student doesn't want to study any social science anymore, any humanity anymore. And I think it's a bad thing. I think the technical people still need to co-work with the social science, with humanity people to make their product more meaningful for humankind. So interdiscipline is a key for everybody. So all the education need to look into that. Another one I call international, okay? Close nation, that's what we are doing, trilateral, maybe 4, 5, 6 country region together, try to improve the so-called conflicting war, and all the restriction, all the limitation, how do we find a human intelligence to find a collaboration among every country to build a better, beautiful world in the future. Last one is called intergeneration. My personal experience to teach in university, I actually fully believe the young generation has a lot more talent, more knowledge than my generation. It's very clear because they can learn anything from internet. Not like the time I have to learn from school, from textbook, and that's old stuff. Okay, all my professors are old. Whatever they can tell me is almost useless. Only the basic stuff. But today's young generation, a lot more talent, a lot more info. They can collect information for internet. So in terms of the knowledge, they are well ahead of at least my generation. But the problem is they need to find a motivation. In early days, we are motivated to learn because we have nothing to do. We had to learn it and then pass the score to get a better school, and that kind of motivation somehow drives us to be to improve ourselves. But most of the young generation today, like in Taiwan, 100% people can go to college. So getting to a college is no longer any motivation. Getting meaningful life is more important. So how did you trigger their motivation to encourage them a certain thing they can help the world, they can help the society is even more important. So I spend most of the time in school try to trigger, inspire, ignite their motivation to learn. Because after they got inspired, I have zero question they can learn it much better. Okay, so how did you trigger their desire to learn and learn by themselves, for themselves? Okay, that's probably the most important. And the elder generation should work with them. I want to give Jensen as a last example. Jensen Huang was the only young CEO in our customer at TSMC who knows how to manage Morris Chang. Most of the US CEO doesn't like Morris because of he's too elderly and have this strong positional things, and a lot of young CEO doesn't really like it. Okay, so but Jensen somehow has a unique character. His younger generation can work with the 40 years older Morris, and he just recently in Computex he took Morris to the night market. He's probably only one in the world can do that. And I observed his behavior for almost 30 years. So he's a role model of a young generation to work with older. I think we have a lot of young generation today. Learn from Jensen, because the resource is the older generation. You may not like them, but why don't you work with them, understand them, to get a resource for your own benefit? And that's how I encourage the young generation to improve their intergenerational skill. And that's all I want to say. Okay, thank you.
Thank you very much. Thank you very much for the very insightful lessons and intuition about how the AI chip market evolved and what kind of cooperation was needed. 3 types of cooperation is needed. Our next presenter is Seongbin Lim. He is a trained mathematician and also the software developer, and he's currently affiliated to the Korea University and Department of Statistics. Please welcome Professor Seongbin Lim.
Okay, thank you very much for invitation. And actually, I'd like to clarify that I'm just a researcher studying computation and AI technology. So not someone just leading a business model as you in these professionals in this room. So please understand what I'm talking today here about saying that the perspective as an engineer. And also I'm currently working with the AGR research, but today's presentation is independent from work there. Okay. So as I introduced, my PhD major is mathematics. So well, if you have an interest in the pure mathematics, I think you'd probably recognize the person in this image at glance. Well, he is a Fields medalist named Professor Terence Tao, which is very famous among the mathematicians because he is known for solving open problems in various fields of the mathematics, not just a single one. This is very remarkable because mathematics is specialized in different fields. And so one person solving difficult problems in the multiple fields of mathematics is very similar to like an Olympic athlete winning the medals in the multiple fields. Well, about a month ago, actually, I read this interview article with Professor Tao, and he predicted that AI will become mathematicians' co-pilot in some days. And it might seem strange, because the pure mathematicians using AIs, because we actually imagine that the mathematicians use a pencil and a paper, right? Well, however, the intelligence that can best understand the formal logic used by mathematicians is like to be AI rather than the ordinary people, right? So even among mathematicians, those with different specialty might not understand each other's work, actually. And so, this is why that the mathematical review is very long to take. Okay, actually it takes about 1 year for review. So actually, on the other hand, given the current pace of language models development, I think it seems possible that the mathematicians could use AI for preliminary verification of their proofs. So today's topic is related about this, okay? And I want to talk about AGI for science, actually not for mathematics. So don't worry about, I'm not talking about the mathematics today, okay? So maybe the word in general is included in the term AGI. It might sound a bit strange to refer to AGI for a specific domain. However, we are already expect the large language models for our commercial purpose, and such as GPT to solve the mathematical problems, or take bar exams, or answer medical knowledge question answers. And this is a very active research area in this field. So driven by this expectation, several startups actually they are promoting the use of AI technology in the education services or medical services or the legal service market. Well, although it is still unclear whether these AI technology-based business model will succeed due to the various reasons, but I firmly believe that this will be achieved in the near future. So at present, I believe that highly possible successful business sectors that large language models can achieve in the short term will be these IT technology-based service industries. Well, although there are still entry barriers in terms of license problems to replace the expert labor market, but most developers and the business men actually they think this is just a regulatory problem or political issues rather than a technical one, actually. So, well, of course, those safety and ethical issues are important political matters, and it should not be approached simply from a technological perspective. But today, I just want to focus on talking about the technologies. Okay, then how? How about the AGI for science-based industry? So, can you say that AGI can affect in this industry field as well as IT industries? For example, manufacturing or science-based industry like material science, okay? So this is actually considered a very important field in Korea and Taiwan and Japan, right? Well, many research groups in the science field, actually, they are already attempting to apply deep learning to material and to the drug discoveries. So the demand for AI for science technology is triggered by the Google DeepMind's AlphaFold research and the GNOME research. Actually, they are attracting significant interest to many scientific research groups. And some research groups are attempting to teach physical knowledge to deep learning methods, which is such as the physical informed neural networks, which is called PIN. Well, in those fields of scientific computing, well, this research direction is attracting considerable interest as well as the concerns. However, I want to emphasize that what scientists need is not just the simulations, actually. It is very important to determine whether those material candidates discovered through these deep learning models can actually be synthesized, okay? So identifying highly probable candidate materials and finding methods to synthesize these materials and actually performing experiments are totally different, okay? So, and of course, of course, the simulation problem is also a difficult challenge, but I think there are limitations to the idea that deep learning approach can replace, well, such as physics informed neural network can completely replace existing scientific computing method. And it would be a posture to consider them as a key players in this industry. So we cannot expect that just simulation level deep learning method would be a key player in the science for AI for science. Then what we need more in this field? Well, I guess, well, I agree that a deep learning model to solve a specific problem is also very helpful in discovering candidates. However, what we need more is an AI assistant that can interact with the humans, I mean the scientists, and they should use the natural language for interactions, of course, and they could perform repetitive and dangerous experiments instead of the human scientists, of course. And we also expect that those AI should have expert level of scientific knowledge in their intelligence. So in order to enable interaction, it is necessary to understand the human natural language comment, which is nowadays called the prompts. And additionally, to interact with the scientist, you should be able to make a reasoning and engage in conversations based on not only the information input through the prompts, but also the visual information and the scientific knowledge database. So our AGI must understand not just the natural language, but they have to understand about the visual scene understanding, okay? And they have to understand what is the tables or previous graph, the knowledge database. They have to know what is the previous knowledge they actually stacked previously. And that is a very important part in this field. And also, we need a physical arms that capable of executing that human comments, the human prompts. That would also be very unnecessary, okay? Because they have to do what we actually command. So in this matter, actually I call this actually embodied intelligence, which is actually fusion of AGI and robotics, okay? And this will be very required in the AGI for the science field. And this actual direction is not just imagination. Actually, already they are being conducted in the project of the DeepMinds and the Berkeley Robotics Labs, and Carnegie Mellon universities. They're actually doing this research already. Okay? So these are the papers which is presented in the last year. They are actually doing the collaboration between the AGI and the robotics. And if we were to mention the another ingredient for AI for science, and it would be very a possibility of the causal reasoning. So the causal reasoning refers to the statistical methodology of inferring the causal relationship between the variables, which is observed from the data, right? So, and this is a different scientific methodology from the logical reasoning through the deductive method based on the mathematics or the physics. And much of today's scientists actually doing their scientific reasoning based on this causal reasoning stuff. So they are actually analyzing their data based on their experiment. So actually they infer a new knowledge based on their data, and they actually do another experiment, okay? So this is a very important ingredient, what we require for AGI, for the scientific domain. Well, I think I have not enough time for introducing this, actually. So, well, I just want to mention that today's research they showed that the pre-trained language models can be used for decreasing the first discovery and increasing the true causal relationship based on data. So if we combine the statistical method and the language models, actually, many studies actually they showed that the AGI can be used for those statistical analysis. So actually, I believe that, well, actually there are still many challenges to overcome, but we believe that the AGI for science has a very bright future through today's research. Okay, so this is my final slide, and it says that, okay, so I want to summarize what I talk here today. So I think the AGI for IT-based industry is very promising, and also the AGI for science is promising, but we require a lot of effort. First one, we need to collect the high quality data for training the language models. But I want to mention that this is not language models no more. We actually call these foundation models. Why? Because we have to train our models with not only with the text data, we have to train our model with images, and they have to recognize what our body language, so they have to recognize their visionary sensors, and they have to understand what I talk, speech recognition rate, and they have to understand the previous knowledge, okay? So this is called multimodal data, and we need to prepare another next level foundation model that is actually trained on this multimodal data. And for that, we need a lot of high quality data. And as we know that the scientific training is very difficult. If we collect just a junk data from the internet for science, and this is very terrible. Okay? We cannot expect those trained language models can infer right scientific reasoning. And we have to recognize that the current generative AI is insufficient for the science field. Okay? So, well, given the current situation, it is very hard to imagine that the GPT can replace the scientist. So, while AI can show the sufficient potential in the field of mathematics, well, it will encounter limitation in scientific fields that require the repetitive experiment and the calculations. So we need to prepare that the integration between the robotics and AGI. Okay, so, and finally, the advancement in hardware in this field is increasing demand in the future because innovations will be essentially not only in GPUs, but also in the robotics and the battery sectors. Okay, so this is the final slide, and thank you very much for attention.
Thank you very much. Very, very interesting presentation, and it reminds me of the scholars are saying that human technology is, I think it's Marshall McLuhan or somebody. Human technology is the extension of human capacity. So the vehicle is the extension of human legs, and something like that. And this idea of AGI combined with the robotics and other types of technology is definitely the extension of human capacity in many, many kind of unimaginable directions. So our next presenter is, let me open my iPad, Richie Tai. Richie Tai is a provost of Taiwan AI Academy, and it's an AI education institution. So please welcome Richie Tai. Yeah.
Okay, let's talk about industries. I am Taiwan AI Academy provost. I'm also play a advisor role for the Taiwan AI COE Center for the Excellence. We have 9 advisors to give our government strategies and how to adapt the AI into all of the industry. So I just want to share one case for a vertical industry. I call a CNC industry. CNC, it means the computer numerical controls. It's very popular in the machine learning industry. First off, let's recap just mentioned in earlier. Taiwan's our vision or strategies focus on first one, how to adapt AI, apply AI into all the industry, and second one is we manufacturing the world leading chips for the AI computing. Both of the key strategies leading us to adapt our approach to help our industry. As you know, Taiwan already setting the national strategy for AI, something like Japan and Korea. I think our speed and direction and the strategy is similar, but I think still have some different approach. First of all, I just mentioned my organization, Taiwan AI Academy. We are not an institute or a university. We are an organization for non-profit organizations. We built up by enterprise and some suckers from syndicats. And unfortunately, we are so lucky that we got a very support from the society and many industries supporter, and also our president, Lai Ching-de, also our academy's alumni. 3 years ago, he asked me to give talk about what's the AI, and he is a doctor, but he have a much curious about how to how's the going into AI, how to the underlying logic. So he paid around maybe 4 hours to take the AI course. I'm so lucky, but after that he decides to join the elections, and so today he become our president. The key, the most important when we think how to adapt the AI into our industry, what's our advantage? Just I mentioned earlier, AI plus semiconductors is a course. So this is our solution stack. I think Korea or Japan may be similar, but we position different industry. What's our advantage? The top is chip manufacturer. I think include Samsung, Intel, TSMC. But TSMC, in this moment, he occupies around 61% of chip designs. Chip producer. But for the advanced chip, he dominate around 90% logic. I mean, not logic, not memory, logic chips. And second tier is IC design. IC design, the top 10 designer, Taiwan has 3 companies: MediaTek, Realtek, and Novatech. Yep. And third, the tier 3 is the framework. I think the key player, all of it come from US, Google, Meta, CUDA. Yep. Then called a platform label. Platform different has edge and the computing and the cloud. And clouds are the key companies. All of them come from the AI server. But Taiwan's have no branding AI servers. All of them, the OEM, ODMs manufacture. In this moment, the market share is 90%. Produce AI server for the NVIDIA, AMD. Yeah. Then fourth and the fifth label I don't mention about it, but let's I just going to talk about the industry, how to adapt this core advantage into the different industry. This is the map is quite important. We have taken use over the maybe over the past 5 years. How to train our knowledge worker and all the industries employees into the AIs. From left side to the right side, we call the engineer path. And from right side to left side, we call the manager path. Why? Because we ask all the manager have to understand how to adapt their domain knowledge plus AI. Then they can select one core technology, even something like computation, computer vision, or just mention NLP or others. Then they just need to have a ability to communicate with the engineer. On the other hand, for engineer, you have to hands-on. You have to use the framework and the skill to build up themselves how to use the AI tool and the technology. Then you have to select one field, something like NLP, large language model, others. Then it can contribute one of the industry. That's our approach. So this map we call the industry AI map. A very interesting things most manufacturing in Taiwan totally we have 23 million population, and we have 1.6 million companies, but we have a small and the medium enterprise take around 98%. Only 2 companies are large, we call large companies. The the difference from Korea and China and Japan. So that's the reason we need to help our SME companies. If we check all of the AI technology adapt in smart manufacturing, is in this moment it's still rarely, because it has entry barriers. It's hard to adapt AI because resources, labor skill, and others something like computing power. So it's very hard. But even that, we still need to help our SME, because our employees over themselves are SME. So that's a very key. Let me give samples. CNC machining industry. His challenge, there are 4 challenges. First one is a small batch diversity. I think some of you maybe know these industries. The second one is a labor shortage. As just we talked about, we also have a very low birth rate. So it's a big challenge for Japan and South Korea, Taiwan, the same. And the third one is a talent gap, because before LLM, or we call it ChatGPT, generative AI, it's very hard to adapt AI, because you need to clean the data, then labeling, then train up model, then fine tune, then deployment, and again. So it's very hard. And for the challenges come from this industry, because this industry need to adaptable and reusable models, and also they have a need to more the skillful employee can use the AI. So there's a very big gap in talents and resources. So how to do? Our objective setting first goal is open platform. It have to be open platform, because we use the open source or open the source model, can share platform infrastructure and the functional module for across the industry. In the CNC industry, Taiwan around has 3,000 companies, so that's quite important. We have to put all together and to use the similar model, then they can fine tune. The second one is a model, just the next one is speaker says, we use the pre-trained model with the few shop, similar like foundation model, but it's a little bit of difference. Foundation model most of it come from larger language model, but we call the few shop model with the can pre-train. So we target this build a model, target to adapt a pre-trained model to different workpiece. Yeah. This CNC machines. We use the sensor and put on the sensor surrounding the machine, then can build up virtual measurements and analysis. These are real pictures. We put the sensor of include speeder and listening the different sensors, torrent. Approaches quality prediction model execution process. So have two stages. This is a real results system for the online predictions for machine learning errors of less machine operations. There's results before and after. So we did and get a very well in job for this case, and also deployed to 3 user or companies to use the open models, can deployment others in the companies. So after fine tunes, it could be very well. It's just only 2 shops to fine tune. Okay. Contribution. The goals we hope this solution can help our SME industry, CNC industry can reduce their cost. The second one is can control their precise in process, and third one is operational process automation. That's just mentions we hope to robotics and a picture model plus automations can be to fulfillment smart manufacturing in the futures. Let's improve the competition. We also encourage them to join the worldwide conference. Got a very good voice from their potential customers. So we try to move their position from the left side to the right side to take more advantage and can face the more competitions from Germany and Sweden, maybe Japan's machine CNC industry is quite very strong. So I think South Korea is still is also. Okay. After that, I think talk about actually is NVIDIA or AMD's in this year's Computex. Both of them CEO they talk about they are building their ecosystem in Taiwan for their GPU or we call next generation's computing. But I think we still have a lot of rooms can collaborate with Japan and South Korea. Why? Because this is last year's AI index. Korea is number 6 and Japan is 12. Taiwan 26. We still a lot of long way to go. Yeah, because I think the two key elements. One is our operating environment. I mean, we need to more implementation for SME because just I mentioned, we are the structure of the economic. Most of it come from small companies. The second one is investment for I think the quite important entrepreneurship energy. I think Taiwan is behind Japan and South Korea. Could be I think South Korea more than could be the number 1 and number 2 is Japan and Taiwan is behind. And also the government strategy is quite important because it's need to very precise and very clear. So that's a reason I mentioned. So we have to learn from the Korea and Japan. So that's one slide. First one I just mentioned how to adapt the AI integrates into the manufacturing. The second one is I just give a sample deployment, open platform development. Also, we talk about the pre-trained model and future learnings, something like foundation models for this industry. And the third one's fourth, real-time quality prediction is quite important. We can integrate with robotics and others, a larger language model in the futures. And finally, I think a competition advantage, we need to cooperate with Japan and South Korea to build up at least a more solid supply chain ecosystem. Thank you for your attention. Thank you.
Thank you. So we will have a short break to 3:05, 15-minute break, and we will get together for discussion. Thank you. I will see you in 15 minutes. Okay, so we will start the discussion session, and we have two discussants. And the first discussant is Professor Kilgon Ko. He's a data scientist at the Graduate School of Public Administration in Seoul National University. And our second discussant is Kai-Shen Wang, who presented right before. So we'll have short discussion from each of them, and then we'll open the floor and take a question from the audience or responses from the presenters. Okay, I will give the mic to Professor Gilgon Ko. Please welcome.
Thank you. Thank you very much. I'm very honored to be here. Actually, I didn't expect these kinds of diverse issues has been discussed in the sessions. I just thought that this session is mainly for the technological issues, but all the presenters covers variety of the issues, which is the shared as some same topics. So I want to bring the couple of the keywords which encompass the different presentations. First keyword I found was the collaboration. The AI is kind of the algorithm, somebody say, but the AI also related to the hardware like AI chips. And also this AI is related to the utilizations. AI should be used for improving the quality of life and the efficiency of our industries. And to do so, we need the collaborative approach. So all the presenters emphasize why AI cannot stand alone. We have to look at other side, other industry, other technology, other disciplines, and even the other generations. So that is, I think, very important message that we share together today. And the second, the keyword I found was that we are talking about AI. However, this AI now more than just technologies. It's dramatically changed the different industries. Especially, I'm very impressed about the discussion from the Li Chai. He emphasized that AI is integrated into the manufacturing sector, especially the CNC, and it helps the small and the medium enterprises. We thought that this AI is only for the big companies, but this can be used for helping the SMEs. So this would be, I think, a good message for the China, the Taiwan, the Japan, and the South Korea, which have very strong manufacturing industries. So then if I go to some little bit the details of each presenters, I want to the comments, give some comments, and also raise some questions. Regarding the Kai-Shen Huang, I think this is very important because indexes sometimes are very influential, designing the global norms and even the making the industries decide where to invest the money. And also the indexes also provide some kinds of diagnosis of the weakness and the strengths of each country's AI ecologies. But unfortunately, these indexes have been developed by some very renowned universities or renowned research institute, but they fail to consider some contextualities of the different countries, especially East Asia. For example, in South Korea, we do not, actually the Google is a very powerful platform for searching the information, but many Koreans use the neighbor, local, the platform. And this is not counted by the global indexes. When they do the text analysis, how to use this AI and which AI they are mainly targeted, then they use the Google text analysis. However, they fail to use the neighbor. It means that the underestimation or the misinterpretation of the status of AI of the South Korea. The similar thing happens in the Japan. Although the Google is very powerful in the Japan, but around the 20% or the more than that, the Japanese use the Yahoo for searching the information. The Taiwan use the Google as well as the Baidu. So we need to develop the localize the informations. But unfortunately, this kind of effort is underestimated. And the Dr. Kai-Shen Huang raised these issues, and even the indexes are too much distorted because it failed to represent the uniqueness of Taiwan. I very much agree with that. The Taiwan is the very important countries for developing the AI ecologies in the world. But Taiwan is just a part of the China in the global statistics. So this may underestimate the role of the Taiwan. So I think that kinds of the data distortion will be a very serious challenge to us. Then how can we make our voice to the world based on the evidences? How can we produce the more relevant evidences or statistics for correctly evaluate the Japan, the Korea, or the Taiwan? That will be very challenging. So international effort among these East Asian countries should be done. And my question is how we can step forward to develop the information or indexes for understanding AI status of 3 countries. During the presentation is very challenging because I'm not the hardware technician. However, he properly raised the issues that the algorithm cannot be developed without the proper hardwares. And he overviews the development of this hardware. And also the interesting thing was that there is the gap between the algorithm and the chip development. And my question is, if there is such a gap, then how can the algorithm developers and the chip developers work together to shorten this gap? And I want to get some the comments or ideas where there are any effort to reduce this gap between the chip makers and the algorithm developers. And Konrad's the presentation was very impressive. He emphasized the collaboration among the disciplines, nations, and the generation. And the most impressive part was the generation. I teach the statistic to our students, and when I teach the students the statistic, then students say, why do we need the mathematics? We just need a ChatGPT. We just need some software. Should we learn the mathematics? Then my answer is, if you learn the mathematics, then you can correctly understand basic logics. Please, a little bit study hard. But my voice is very small. My students always try to challenge. But that's I think the situation we have. We have the experience. We have the basic and the very sound foundation of the algorithm and the models of the AI. But the young generation always wants to quickly solve their problems. So we needed to collaborate between the young and the older generation together. Because without this balanced approach, I think there must be defected the development of the AI. So the big issues to us is how we expedite this kinds of collaboration among the disciplines, nations, or the generations. Is this the task of the industries, or is this the task of the government or society or academia? We have to the comprehensive approach to expedite the collaboration. I want to listen some idea insight from all the audiences. And Songbin Lim's the papers. Oh yes, how mathematicians use the AI program. Yes, I fully agree that nowadays I don't use much the pencil. I ask the ChatGPT to solve the equations. Then I think around 70% of my question is well answered by the ChatGPT, but the 30% is totally wrong. But still, the more mathematicians will use the AI programs, and simulation is very important. However, the main point Dr. Lim raised was that simulation is just one thing. This mathematics is just one thing. The synthesis is another. So how we apply these things to make real things happen in the industries. So this kinds of ideal algorithm cannot be implemented or cannot come true in the real world in the manufacturing. So we needed to reduce these kinds of the gaps. And to do so, he also emphasized the causal kinds of the inferences. But unfortunately, the AI, at the beginning of the AI, many experts tried to rely on the causal approaches. Then later on, because of the deep learnings, the correlation approach becomes a dominance. And we return to this causal approach. Then how we balance between this causal and the correlation approaches in the 21st century's AI. That is very big challenge, especially in the social science area or the public policy areas. We have to persuade our citizens, but citizens cannot be persuaded just showing the correlation. They want to know the logic or the correlations, but how this AI can expedite to this the correlation causal explanations. That is very challenging, and we have done a lot to fix this problem, but still we remains very unknown regarding this the causal and the correlations approaches. And finally, the Rich Chai's papers is also very, very much interesting. Our Seoul Asian universities has the small research teams. They how we use this AI for developing the government's strategy. And one of our topic nowadays is related to these issues. We emphasize the smart manufacturing, smart medical, the retail finance, and edge operations. And this means that application of AI to the real world industries. And we have not much understood how these kinds of the integration between the AI and the industrial sectors happens. But Taiwan show very good the example, especially the model-based approach. They don't need to have the big model, the big data, but already if they have some pre-trained model and this is the well utilized, then we can use this pre-trained model for helping the SMEs. That is, I think, the very the insightful and useful the understanding to utilize the AI. My question to this is okay, then there must be some kinds of the competitions among the SMEs, and the one model or the one companies do not want to share their data with the other companies. It means that it is very difficult to develop highly qualified the pre-trained model. Then how we make this the pre-trained model as a common goods? How we collect the more data to improve this commonly used the AI models. That is, I think, very challenging. So I want to know how the Taiwanese companies share this data and share the pre-trained model together, and how they improve the quality of the models. And finally, my final concern today is that, okay, we talk about the independent issues, but the role of the government, lot of the universities, and a lot of the societies are not much discursive. For example, to develop the huge LLM models, we need the capital, we need the money. Then who can fund the money? In Asia, as the Professor Chai mentions, we do not, in Taiwan, they don't have the big companies who can fund this kinds of big AI model. Then sometimes government play a role. Then how the government make a role to support or to subsidize these efforts of the business? And the universities is the same problem. We already lose the good university professors to the private sectors. Then how we secure the good experts into the universities? That is the big issues. And also the societies. There is huge resistance within the society utilizing the AI. And how we make this society to work together with the technicians or the government officials or the businessmen to use this AI toward the proper or the desirable directions. So I want to talk about the role of the different actors in our societies to properly use this new technology. Thank you very much.
Thank you, Kai-shen.
Thank you so much, Professor Go. And I myself am not an expert at AI industry, but I just want to echo some of your suggestions on AI index. So it's true that these reports are far too influential, and this can be a problem for countries like Taiwan, Korea, and Japan, which actually didn't have a say about how this index were made. That can be very problematic because, for example, when I was at DSET, I was actually asked by my boss to work on some policy recommendations within a rather short period of time when these reports were released. But with a report like Oxford Insight, with more than 40% of the data related to Taiwan was actually imputed, which means these data are not real data on Taiwan's performance in the area of AI. It's almost impossible for me to see it as a reliable data source. So that's my first feedback on your suggestion. So the next point is, if we want to have a new index, a new AI index, I think that in general, the principle is we don't want something that's too expensive or clumsy to be useful, but we also don't want an index that's too fragmented either. So that's the sort of direction we are trying to work on. I didn't really have much time to elaborate on the methodology or type of indicators we should develop together. And I'm hoping that we could have some feedback from the flow, especially how we can normalize and operationalize the data to make them explicit and legitimate to the policymakers across these 3 countries. Any feedback or suggestion would be much appreciated. Thank you.
Thank you. So I'll take a question from the audience. If you have any question, and please specify where the question headed.
Thank you so much. Very quickly, 2 questions. One, on your point about the AI index and how to make it better. I wonder, should we create a brand new index, or should we just tell these existing index creators that, you got this wrong, you need to clarify this data? Because sure, I mean, if there's enough funding, then it'll be nice to have our own global new AI index. But I think it might be much easier to just tell them that you're getting these wrong so that from the next year, the ranking is improved. And then my second question is a little bit more expansive, and it's to not just the panelists, but everyone really. Today's presentation really focused on the opportunities and uses of AI. And I wonder if we should, in the next time, have a session focusing on the abuse and misuse of AI as well, because we first have to identify various threats that exist in, for example, the information sphere through disinformation by using generative AI on text, images, audios, and videos in this election year. And also, there's military uses. It's transforming warfare. There's sophisticated cyber attacks going on. And we have to identify these threats and then think about, well, how can 3 countries cooperate in responding to these threats? And then we can also think and analyze about what would these government intervention have, what kind of impact this would have on the R&D development of AI and so on. And I feel like, it's nice to talk about the opportunities and the new things that this would bring to better our quality of life, but we also have to probably look at the negative aspect as well.
Okay, thank you. Any other comment or questions from the presenters also? No comment? Or from the discussion, do you want to?
Regarding your first questions, do we have to develop brand new ones? Do we fix some biases? This is big controversial issues among the international index developers. For example, the Transparency International, the corruption perception indexes. We have to in that international indexes, we have to distinguish between the between variation and the within variations. If we have the multiple indexes, then the rank of the countries would be pretty much highly correlated across the different indexes. So it means that the status of the countries itself is not much different across the different indexes. But within variation is very much different. It means that over the last 10 years, how South Korea's corruption level has the changed. Then one indexes show very different patterns compared to the other indexes. When we want to develop the Asian version of the indexes, it should be useful for each Asian countries. The first thing is what kinds of the information we need for the Asian countries. That question should be done. We have to develop usable indexes. The global index per se looks very fancy, but already there is some things out there. And to make this new indexes more useful, it'll be better to focus on the local issues to measures. I think in that sense that I don't think we have to develop so brand new global level one, but we focus more on the local issues, and the issue should be correctly measured by the new one. And I totally agree with this abuse of AI. And this is a very significant problem. The security attacks, cybersecurity attacks, is the experience by all the three countries. But in fact, we do not share these kinds of the experiences. So this is the one of the most important part. We collaborate with each other, but the reality is we fail to collaborate. So in that sense, obviously AI or the identifying some risk and how to solve this kinds of risk or threat, that should be done. That kind of task should be done through the collaborations. If not, it will be a very serious challenge, and even our civil societies cannot bear these kinds of the risk anymore. That's the reason that we always have the political debate between the pro-AI versus anti-AI. So in that regards, I think you raised very proper questions, and also this question emphasized the importance of the collaboration among three countries.
Thank you. Any other final comment or remark? Yeah, Professor Kwon and
I have some specific questions to Provost Chai. So we have discussed about the possibility of usage of AI for the manufacturing. So for example, Provost Chai mentioned some example about CNC automation. So we witnesses that there's some great potential of the application of AI. The question in my mind is that the possibility of the application of AI for the semiconductor manufacturing automation. So all of us, I mean the South Korea, Japan, and Taiwan will experience a serious lack of trained engineers and the human resources in the next few years. It means that we need to replace most of the semiconductor manufacturing lines with some automated system, including AI and AI-driven robots. So in terms of this semiconductor manufacturing automation, so what kind of potential those three countries can share with each other, and what is the uncertainties underlying this automation? Because the people I met in recent days about this, the possibility of the semiconductor manufacturing automation is actually relatively limited compared to the other manufacturing system. It's really delicate, so it takes much more data, energies, and the time to make some more reliable automation. So what kind of the potentials or opportunities or ideas can we share with each other? So I would like to share with this question with all of us.
Let me comment a little bit on semiconductor manufacturing, especially 12-inch 300 millimeter. It has all the work standard. So in terms of semiconductor manufacturing, this is probably one of the easiest one. I should say one of the most automated one. All the equipment company, everything is follow the world standard from SEMI 300. So the lesson learned for semiconductor manufacturing is the world, starting from US, define the standard, everybody follow. Okay. The problem is for any other manufacturing, there is no such organization define the standard. So first to learn is how does each kind of a manufacturing industry define their own standard, so that everybody in the world focus on a very effective way of making everything automated. Okay, so I'm talking about the automation part of it. So if you go to semiconductor manufacturing fab, you don't see robot outside. Everything is inside because it's being defined. So equipment has this robot coming out, take the box, take it wafer in and out. So that's probably the most standard process in the world. And the problem is for other industry, they are not big enough, or they are not start with the standard from the very beginning. This is happening in early 2000. Okay, it's been more than 20 years. So one thing you can learn from is can that industry define a standard, and then everybody to follow. Typically, this is done by U.S., but they only focus on the big one. They don't care about CNC, I assume. So any country want to do a CNC, maybe we'll start from that country, start with their own standard. But again, when this industry is so small, not many people care. Okay, so that's why you create a kind of many arm, whatever the 6 or 3 axis kind of a robot. Try to be more flexible to deal with many things, because there's no real standard in that industry. Okay, so typically the standard always come from the big industry because it make more sense to do that. For the small industry, it's hard to do it, and it need to be localized. So the most difficult one for semiconductor is not the automation part of it. Is when you have a problem, we still need a lot of people to resolve it. So yield problem and so on. We have a so-called out of control SOP, out of spec SOP. How did you put that SOP into intelligence so that the computer to have that kind of intelligence? I actually call it as a digital twin. It's a little bit different digital twin when you have a VR kind of things. Basically, digital twin is a expert system. You take a human brain. Is that SOP generic enough to solve the problem? If you can do that, you don't need many people. In semiconductor, this is the best industry to have a no-man factory. If you can solve the engineering kind of reaction problem out of spec, out of control issue, okay, yield improvement issue. The remaining things is, for example, you have a broken wafer and need somebody to do it, because that is less, it's probably not easy to be fully automated. So only remain a very few, tedious job. That one you can have a high school graduate just pick up the wafer out, and that itself you don't need an automation. You can use the cheapest labor to deal with that one. So semiconductor definitely is one of the role model to do it, but again, it require industry size. Just feedback for you. Yeah.
So thanks everybody for presentation and discussion and participation. It's a great conference. Tomorrow we will have another important topic of energy, and we will have another discussion. So we will close today's session. So please